Dear students, today we are going to learn about alkynes. You know, alkynes are a triple bonded compound. One of the bond is sigma bond and the other two bonds are pi bond. And which is the simplest alkyne? Simplest alkyne is ethine. Ethine is the simplest alkyne, or ethane is also called as acetylene. Okay, acetylene is the simplest alkane and its formula is CH triple bond CH. This is the formula of ethane or acetylene. Now let's see the preparation. On an industrial scale, ethane is prepared from calcium carbide. This is the industrial method of preparation of acetylene. That is from calcium carbide. Calcium carbide is treated with water to get ethane. Okay, calcium carbide on treating with water gives ethane. This is the industrial method of preparation of ethane. And this calcium carbide is obtained from quicklime on reaction with coke. See the equation, calcium carbide CaC2 on reaction with water H2O. This gives ethane C2H2. Ethane CH triple bond CH C2H2 plus calcium hydroxide. For each reaction, this calcium carbide is prepared at that time. Okay, it is prepared from calcium oxide. Okay, calcium oxide on reaction with quicklime produces calcium carbide, and this calcium carbide on reaction with water produces ethane. This is the industrial method of preparation of ethane. Second method is from vicinal dihalides. You know what are vicinal dihalides? What are weak dihalides? Those dihalides in which the halogen atoms are present in adjacent carbon atoms are called weak dihalides. When this vicinal dihalides are treating with an alcoholic solution of potassium hydroxide, then ethane is obtained. For example, say this reaction CH2Br, CH2Br. This is a vicinal dihalide. This on treating with an alcoholic solution of potassium hydroxide. Potassium hydroxide alcohol. Okay, alcoholic solution of potassium hydroxide, and you know this alcoholic solution of potassium hydroxide dehydrohalogenation reaction takes place. Okay, so here which reaction takes place? Dehydrohalogenation reaction. What is meant by dehydrohalogenation? Removal of hydrogen and halogen. So on treating with alcoholic NOH, first a molecule of hydrogen and a halogen is eliminated. So here one halogen and from this a hydrogen is eliminated. So that the product obtained is CHBr double bond CH2. Again, this is made to react with an alcoholic solution of potassium hydroxide. Okay. Then again what happens? From here, a halogen. Again dehydrohalogenation. A halogen and a hydrogen from here is eliminated. And so that what will be the product obtained? CH. Then here it becomes a triple bond. Again CH. CH triple bond CH, that is ethane is obtained. These are the two methods of preparation of alkynes. In alkynes we need to study only these two methods for the preparation of ethane. Okay. Now let's see the properties. Physical properties of alkynes are similar to that of alkanes and alkenes. See its chemical properties, and chemical properties, the chemical reactions, first reactions are addition reactions. As double bond, as pi bonds are present, addition reactions takes place. Okay, addition reactions. First reaction is the addition of dihydrogen. Addition of dihydrogen means hydrogenation process. Okay. And here to a triple bonded compound, for example, in the case of acetylene, CH triple bond CH, a hydrogen molecule is added in presence of a catalyst, platinum, nickel or palladium. So here platinum catalyst can be used. Then a molecule of hydrogen, this is added to both the side of a pi bond. Then this gives CH2. One bond breaks here and CH2 double bond CH2 is obtained. And again, if hydrogen molecule is added, then what happens? Second pi bond also breaks and hydrogen is added on both sides of the bond, and then it becomes a saturated compound. CH3 single bond CH3, a saturated compound is obtained. Then a second addition reaction is the addition of halogens. For example, addition of a chlorine or a bromine, etc. Okay, addition of a halogen. So, for example, here acetylene. Can take the example of acetylene itself. Okay, acetylene on reaction with the bromine. Bromination. If bromine is added, the process is called bromination. If chlorine is added, the process is called chlorination. So here halogen bromine is added to this, and first a molecule of bromine is added to CH triple bond CH, and one of the pi bond breaks and Br2 is added on both sides of the bond, and hence it becomes a CHBr double bond CHBr is obtained. And again bromine can be added. Okay, then what happens? Again this bromine is added to both sides of the bond, and then it becomes a CHBr, and this becomes single bond. Again a bromine is also added to this. Okay, this is bromination. Okay, so when bromine is added to, or bromine water is added to an unsaturated compound, bromine has a brown color, and the brown color or reddish orange color of bromine is decolorized when bromine is added to a double bonded compound or a triple bonded compound. That is, to an unsaturated compound, if bromine is added, then it becomes saturated. So, the reddish brown color of bromine water gets decolorized. So, this can be used as a test for unsaturation. Addition of hydrogen halides. Addition of hydrogen halide HX. HX is added to a triple bonded compound, just like as we add hydrogen halide to a double bonded compound. That is by following which rule? Markovnikov's rule. Okay, so here we have to follow Markovnikov's rule. So if we are adding hydrogen halide to a symmetrical alkene like ethene, it may not create a problem here. That is, for example, CH triple bond CH, and if HBr is added to CH triple bond CH, then one molecule of HBr is added to this. First, the addition takes place by breaking one of the pi bond. So one of the pi bond breaks, and hydrogen can be added on this side or this side. Okay, any side you can add hydrogen, HBr, you can add like this. So it becomes a CH2 double bond CHBr. Then again you can add HBr. Okay, if again HBr is added, then the addition of HBr takes place in accordance with the Markovnikov's rule. Now it is not symmetrical. Symmetrical means now the number of hydrogen atoms on both sides of the double bond are not equal here. So you have to use this Markovnikov's rule. Okay, according to Markovnikov's rule, the negative part of the reagent goes to the carbon containing lesser number of hydrogen. So which is the negative part in HBr? Br. Br is the negative part. It goes to the carbon containing lesser number of hydrogen. So here, where this Br goes? Here. So what will be the product obtained when HBr is added here again? Hydrogen goes to this side and Br go to another side. So the product will be CH3 single bond CHBr2. Okay, this will be the product on the addition of hydrogen halide on ethane. Okay, now let's see another alkane, that is for example CH3 single bond C triple bond CH propyne. Okay, addition of hydrogen halide takes place in propyne. So HBr is added to propyne. So this negative part goes to which carbon here? C and CH is here. Okay, negative part has to go to the carbon which contain lesser number of hydrogen. Even hydrogen illa. So which position this Br will go? Here. Okay, HBr is added to the double bond and Br goes to this position and hydrogen goes to this. So what will be formed here? CH3 single bond CBr double bond CH2. Again HBr can be added here. So when HBr is added here also negative part goes to which carbon? This carbon. So what will be formed here? CH3 CBr2Br single bond CH3. If this reaction takes place in the presence of peroxide, then the reverse of Markovnikov's addition reaction takes place and what is formed? Then anti-Markovnikov's addition takes place here. Okay. Then the fourth one is the addition of water. So the addition of water H2O you may write as HOH. Okay, HOH. Addition of water also takes place in the similar way as that of a hydrogen halide. That is Markovnikov's addition reaction is followed here also. Okay, so first CH in the case of acetylene molecule, CH triple bond CH when water is added as H2O or as HOH. This is the negative part. OH part is a negative. So negative and positive. So here as it is symmetrical, equal number of hydrogens are present on both sides of the bond. Then here we can add hydrogen on one side and OH on another side. So let's add here hydrogen and here OH. So this becomes a CH3 double bond. Sorry, CH2 double bond CHOH. Okay, CH2 double bond CHOH is formed. Again, HOH can be added. Okay, double bond is here. HOH can be added. Here, the negative part of the reagent goes to the carbon containing lesser number of hydrogen. So here, lesser number of hydrogen. Here only one hydrogen, here two hydrogen. Okay, don't consider the functional group OH. Okay. So here, OH will go to which carbon? Here. Okay, here itself OH goes and then this becomes CH3 single bond CHOH. And this is a highly unstable molecule as two OH appears in the same carbon. So from this a molecule of water can be eliminated and this exists as a CH3 single bond CHO. Okay, CH3 single bond CHO aldehyde. It exists as an aldehyde. This is one of the method, or this can directly undergoes isomerization. Okay, directly undergoes isomerization and this hydrogen can move to this carbon and forms a CH3 single bond CHO. Aldehyde can be formed by isomerization also. Okay, clear? The next is the polymerization reactions. The process of formation of polymers from monomers are called polymerization. So in acetylene, two types of polymerization is possible: linear polymerization and cyclic polymerization. Linear polymerization and cyclic polymerization. In linear polymerization, this acetylene polymerizes. Acetylene acts as a monomer and it undergoes polymerization and forms a polyacetylene. Okay, linear polymerization of acetylene gives polyacetylene. And here you have to give importance to the next type of polymerization, that is the cyclic polymerization. cyclic polymerization of acetylene or ethine gives to a very important compound called benzene. Okay, acetylene or ethane undergoes a cyclic polymerization and forms an aromatic compound or the most important hydrocarbon in the aromatic section, that is benzene. Okay, this ethine is passed through red hot iron tube. Okay, ethine is passed through red hot iron tube. Okay, red hot iron tube at 873 Kelvin. Then this ethine, 3 molecules of ethane are used, and this ethane undergoes polymerization, cyclic polymerization, and then forms benzene. So this is the method of preparation of benzene. Okay, it is an important property of alkyne or ethyne, and it is a very important method of preparation of benzene. Benzene is usually prepared by this method. Okay, ethane. How many molecules of ethane is needed here? 3 molecules of ethane. Let's write the 3 molecules of ethane like this. Listen here, CH, triple bond CH. Okay, this is one molecule. Another molecule you can write like this, CH, triple bond CH. Okay, then next molecule you can write here, CH, triple bond CH. Okay, when this is passed through red hot iron at 873 Kelvin, cyclic polymerization occurs. So here one of the bond is shifted here. Here one is shifted in between these two. Here also one shifted between these two. Cyclic polymerization. So what happens? CH, this becomes double bond. Okay. So here CH, double bond CH. And here, as the bond is shifted here, here a single bond is formed. Then this CH. Then here becomes double bond. Again the CH. Then this bond is shifted here, so it forms a single bond. This CH. This will be double bond. Then this CH. Again the bond is shifted here, single bond. CH, double bond, CH, single bond CH, double bond CH, single bond CH, double bond CH, single bond CH. So this is the compound benzene. Benzene contains alternate double and single bonds. Okay, so benzene, this is the method of preparation of benzene. So benzene can be prepared by the cyclic polymerization of acetylene. When acetylene is passed through red hot iron tube at 873 Kelvin, benzene is obtained. So study the preparation of benzene. So this is the preparation of benzene as well as one of the property of acetylene or ethyne. Okay, so how will you write the structure of benzene? Yeah, CH, okay, CH, double bond, CH, single bond, CH, double bond, CH, then single bond, CH, double bond, CH, single bond. Okay, alternate double and single bonds. You can also write like this, CH. Here you put the double bond. So here you, in this structure, you can put a single bond here, CH, single bond CH. Then this one bond will be double bond CH. Here single bond CH. Here you can use double bond CH. Single bond CH, double bond. So you have to put double bond and single bond in alternate positions. Okay, this is the structure of benzene. Okay, this you can call as the resonating structure. Okay, resonating structure of benzene contains alternate, double and single bonds. And without this carbon and hydrogen, you can use the bond line structure of benzene. Okay, benzene, the bond line structure of benzene. This one here, double bond, single bond, double bond, single bond. This is benzene or resonating structure, double bond, single, double, single, double. Okay, this is the resonating structure. And so, how many double bonds are present here? 3 double bonds. Okay, 3 double bonds are present. That is, these pi electrons. Double bond means pi electrons. These pi electrons, here a double bond is present means pi electron is present in all the carbon atoms here. This pi electron is present in this carbon. The pi electron of this is present in this carbon. So these 2 carbon atoms have pi electrons. Then when this bond breaks, then these 2 have pi electrons. For this bond, these 2 have pi electrons. That is, all the carbon atoms have pi electrons. When you consider this one, these 2 pi electrons are present here and here. Pi electrons are present in all the carbon atoms. That is, these pi electrons are not localized on a particular carbon. The pi electrons are delocalized on all the carbon atoms. Okay, pi electrons are delocalized on all the carbon atoms. So those delocalization of pi electron you can write like this. That is, this carbon has pi electrons, the another carbon has pi electrons, all the carbon has pi electrons. Okay, the delocalization of pi electrons you can represent like this. Okay, the circle indicates that the pi electrons are delocalized. Okay, or you can write this as a structure. Here I used a dotted line circle, dotted circle, and you can use a solid circle too. Okay, so for simplicity we are using benzene like this. When we write benzene, we are just writing the hexagonal shape like this and a circle inside. This is benzene. Okay, circle inside means what is the circle represent? Circle represents the pi electrons. Pi electrons are delocalized. It is not localized on a particular carbon atom. It is delocalized on all the carbon atom. Appo oru pi electron, it belongs to e carbon or e carbon or e carbon, we cannot say it. Okay, അത് ഏത് കാർബൺ ആണ് ഏത് കാർബണിലുണ്ട് എന്ന് നമുക്ക് പറയാൻ പറ്റത്തില്ല. Okay, the pi electrons are delocalized in all the carbon atoms or delocalized in the benzene ring. Okay, this benzene can also be prepared from phenol. What is phenol? Benzene ringil OH വരുന്നതാണ് phenol. This is the shape of phenol. Okay, so benzene can be prepared from phenol on treating with zinc powder. On heating with zinc powder, phenol is reduced to benzene. Phenol in the OH അങ്ങോട്ട് പോയിട്ട് benzene is formed when it is treated with zinc. So zinc oxide is formed here along with the zinc oxide. Okay, so this is one of the method of preparation of benzene, but benzene is usually prepared from acetylene. So study the 2 methods of preparation of benzene. One, the preparation from acetylene, cyclic polymerization of acetylene, and second one, in the laboratory, benzene is usually prepared by this method, that is from phenol on treating with the zinc, benzene is obtained. Okay. Now let's see some of its properties. Physical properties, benzene aromatic compound. Benzene is an aromatic compound, so it's non-polar molecule, and they are usually colorless liquids or solids, and they have a unique smell, so they are called aromatic. Aroma means smell. Okay, they have a characteristic smell also. Then aromatic compounds usually not only benzene, naphthalene is an aromatic compound. Naphthalene is used as a moth repellent. Okay, moth balls. It is used as a moth ball, and usually they are immiscible with water as they are non-polar, but they are readily soluble in organic solvents. Okay, and they burns with a sooty flame. Sooty flame, you know, smoky flame. Okay, burns with a smoky flame as a due to the presence of unsaturation in them. Okay. So some of the chemical reactions of benzene, and the chemical reactions of benzene comes under the electrophilic substitution reaction. Benzene undergoes an electrophilic substitution reaction, and the first reaction is nitration. Nitration means reaction with the nitric acid, HNO3. Okay, reaction with the nitric acid is called a nitration. Okay, any compound or reaction with the nitric acid is called a nitration. So here benzene undergoes nitration. Okay, and for nitration, reaction with the nitric acid is nitration. But for nitration, we are using a mixture called the nitrating mixture. Okay, nitrating mixture is used. Nitrating mixture is nothing but a mixture of concentrated nitric acid and a mixture of concentrated and a sulfuric acid. Okay, nitrating mixture is a mixture of a concentrated nitric acid and a sulfuric acid. And here sulfuric acid provides a medium and nitric acid reacts with the compound, and hence the process is called nitration. So, okay, so benzene on nitration, when nitrated, reacts with the HNO3 and H2SO4. You have to write both the reagents here, that is the nitrating agents or the nitrating mixture, and from HNO3, NO2 group, nitro group, comes to this position of a benzene and forms a nitrobenzene. Benzene on nitration produces nitrobenzene. Okay, benzene on nitration gives nitrobenzene. Then second reaction is halogenation. Halogenation means reaction with the halogens. Okay, for example, benzene on reaction with the chlorine, and this reaction takes place in presence of a Lewis acid, that is anhydrous aluminum chloride, in presence of anhydrous aluminum chloride, and here from chlorine, one of the chlorine molecule attacks here and becomes chlorobenzene. Very simple reactions. On nitration, it produces nitrobenzene, and on chlorination, it produces chlorobenzene. On bromination, it produces bromobenzene. So, on halogenation, haloarenes are obtained. Okay. Then the third method is sulfonation. Sulfonation means reaction with the fuming sulfuric acid, H2SO4. Reaction with the sulfuric acid, fuming sulfuric acid is sulfonation. So benzene on treating with the sulfuric acid, H2SO4, fuming sulfuric acid, benzene sulfonic acid is formed. Means in the benzene ring, SO3H group comes. This is called benzene sulfonic acid. Benzene on nitration produces nitrobenzene, chlorination produces chlorobenzene, and sulfonation produces benzene sulfonic acid. Okay, then next is another important reaction, which is called Friedel-Crafts reaction. Friedel-Crafts reactions are of two. Two types of Friedel-Crafts reactions are there. Friedel-Crafts alkylation reaction and Friedel-Crafts acylation reaction. Okay, Friedel-Crafts reactions are of two: Friedel-Crafts alkylation reaction and the Friedel-Crafts acylation reaction. In Friedel-Crafts alkylation reaction, benzene reacts with an alkyl halide. Benzene reacts with an alkyl halide, and in Friedel-Crafts acylation reaction, benzene reacts with an acyl halide. Okay, when benzene reacts with an acyl halide, the reaction is called Friedel-Crafts acylation reaction, and benzene reacts with alkyl halide, the reaction is called Friedel-Crafts alkylation reaction. And in both the acylation reaction and the alkylation reaction, anhydrous aluminium chloride is used. Okay, anhydrous aluminium chloride is used in both the alkylation reaction and in acylation reaction. Benzene reacts with an alkyl halide in presence of anhydrous aluminium chloride. The reaction is called alkylation reaction. When benzene reacts with acyl halide in presence of anhydrous aluminium chloride, the reaction is called acylation reaction. So let's see the reactions. First, alkylation reaction. Benzene react with an alkyl halide. For example, methyl chloride or chloromethane. Benzene reacts with the methyl chloride in presence of anhydrous aluminium chloride. This is very important reagent in the case of Friedel-Crafts reaction. ഇതില്ല എങ്കിൽ ഈ reaction നടക്കത്തില്ല. Okay, the reaction will take place only in the presence of anhydrous aluminium chloride. So, if anhydrous aluminium chloride is not there, the reaction will not proceed. Okay, so here this is very important. Anhydrous aluminium chloride. Here what happens is methyl groups attacks this carbon. Okay, so toluene is formed. Okay, toluene is formed when benzene on treating with an alkyl halide, that is methyl chloride. This is Friedel-Crafts example of Friedel-Crafts alkylation reaction. Now let's see the acylation reaction. Benzene is treated with an acid chloride. When benzene is treated with an acid chloride like acetyl chloride, CH3COCl. Name of this is acetyl chloride. Okay, this is an example of acid chloride. This is an acid chloride. Acetyl chloride is an acid chloride, and this takes place in presence of anhydrous aluminium chloride. Here, CH3CO groups attacks this benzene ring and COCH3. Name of this compound is acetophenone. A ketone is obtained. Acetophenone. This is toluene. Toluene and acetophenone. Okay, these are the two Friedel-Crafts reactions. Okay, study these reactions of benzene. Okay, nitration, halogenation, sulfonation, and Friedel-Crafts reactions. Okay, next reaction is the reaction of benzene with halogen in the presence of sunlight. If benzene reacts with halogen, that is chlorine, in presence of sunlight, in presence of UV light, all the pi bonds present here breaks. Okay, all the pi bonds breaks and this forms benzene hexachloride. Okay, this is benzene hexachloride. Hydrogen atoms substituted by halogen. Benzene hexachloride is formed when benzene is chlorinated in presence of ultraviolet light. Okay, the formula of this is C6H6Cl2, benzene hexachloride. Okay. So these are the reactions of benzene. Okay, study all these reactions of benzene. Okay, thank you.